Alright, this is the third example that you guys had to do. Okay, again, I identify my x term. Notice my x term is on the right side this time, again, and then you have the constant here hanging around. Alright, so I'll show you the two methods here. So again, I try to identify my stuff here. So here's my x term, and then here's my term without the x, which we call a constant. Okay. So the more traditional way is always to get rid of the one without the x first, right? So notice how it's subtraction. So it's subtracting by a 14. So what I want to do is go ahead and do the opposite. So if it's subtracting by 14, I go ahead and add by 14. But keep in mind, whatever I do to the right side, I have to also do it to the left. So this is adding 14 there. Okay, so this becomes a giant 0, and I bring down the 4x. Then I have to combine these two terms together. So 38 plus 14. So if I do this on the side, 38 plus 14. Okay, I add 8 and 4, this is 12, then I carry the 1. And then I get 52. So this will be 52. Okay, and notice it's a party because they're both positive. That's why I added them together. Okay, now keep in mind over here they're multiplying here. When they're stuck together, the opposite of multiplication is division. So I'm going to go ahead and divide by 4 to get rid of that. That way I could get that giant 1 going. But if I divide by 4 on the right, I also have to divide by 4 on the left. And if I do that correctly here, okay, 4 goes into 52, I believe, 13 times. Okay, 13 times, right? Because a deck of cards is 52, and there's suits of 4. So that's how I got it real quick there. So x is equal to 13. Now again, suppose you're a student that wants to get rid of the 4 first, right? So if we go over here, let me try the other method. Okay, suppose you want to get rid of the 4 first. So let me highlight right here. Again, that's my x term, and this is my constant. So some people like to get rid of the 4 first here. So notice how you're multiplying here by 4. So what we want to do is get rid of that. So I have to divide by 4 because that's the opposite. But like I stated before, if I divide this term by 4, that means I have to divide every other term by 4. So I go ahead and divide by 4 here and here to keep it equal. Okay. Now for this one, right, let me change the color here. So we have 38 divided by 4. That gives us 9.5 is equal to, this creates a 1 here, so you get 1x. And then we're going to divide this one. So we have a minus, and then it's 14 divided by 4. That gives us 3.5. Okay. Now we have to focus and get rid of the minus 3.5 because again, I have to emphasize our goal is to leave x on its own. So notice here that you're subtracting by 3.5, so I have to go ahead and do the opposite, which is add 3.5. And whatever I do to one side, I do to the other. So I have plus 3.5 on this side. Now keep in mind here, this is a giant 0, goes away, and I get x. And since they're right here, these terms are both positive. It's a party, so I have to add them together. So again, if you have trouble adding the decimals, just line up the dots and give it all you got. Okay, so I'm going to add here. This gives me 10. I carry the 1. Okay, and I believe I get 14. No. Yeah, 14. So then I get 14 here. Did I do something wrong? Let me see. 9.5 plus 3.5. Oh no, it's 13. So what did I do wrong here? Oh yeah, it is 13. Duh. Okay. Because that gives me 12, that's 13. There we go. So this is supposed to be 13. There we go. Okay. Yeah, I miscounted there. Sorry about that. Yeah, because I thought I did something wrong there, but I didn't. So that's 13, which is kind of nice. All right. So notice that I do it two different ways. That's how I check my answer, by doing it different, which is kind of nice. Okay. All right. And just make sure you add correctly. Don't be like me there. Okay.